Hello, everyone. We are going to speak about observability. Who is OK with the term observability? Not that much? OK. So what's observability? If I talk about logs and metrics, maybe now it speaks for you. Who is using a time series database among you? Oh, quite a bunch. Let's make a vote. Who is using InfluxDB? Yeah. Prometheus? Yeah. OpenGSDB? 1, OK. 2. Big Graphite. A graphite? Not that much today? Yeah, OK. Something else, maybe, that I missed? Warp 10? Oh, OK. Few guys. Great. So who is operating HAProxy? Yeah, quite a bunch. So there is convergence between the time series database and the HAProxy instance, actually. OK. So the two pillars of observability are metrics and logs. But we will see that actually both are time series with different indexing strategies, actually. So the time series database is really important at this stage. Let's see the difference. HAProxy is really useful in terms of logging. This image comes from the blog of HAProxy and shows the different things that you can get from the log. For example, you have counters, you have status connections, statuses, you have the queues, the connections. You have many insightful things in the log. And actually, it's marvelous. When you operate a solution, to have this kind of information is really, really, really a good thing. But indexing logs can be quite costly. I'm not saying for the previous speakers that Elasticsearch is not a good solution, but given some workload, it can't work for every workload, actually. So on the other side of logs, you have metrics. Metrics are simple data evolving in time, but measured data. Okay? So speaking in terms of HAProxy, what are metrics? Client session rates, rates counters, response times, queues, etc. These kind of metrics are exposed with the Socket API or the Prometheus export. Excuse me, my phone is just vibrating. Up. So there are metrics, but we have seen in the previous slide that there are many metrics into logs too. So the thing is, it's quite important, but it's how we do it. We extract metrics from the log to store only metrics. Why? Because if you see in this slide, if you have to store a log, storing a log is actually not an issue because you have good storing strategies. But if you want to query it and use a Kibana, for example, you have to index it. And indexing logs have a cost. And this cost can be mitigated if you extract the value inside the logs, aggregate it in real time, for example, and just flush the corresponding metrics. So here is the difference. Above, you have the full log. And if you want to build an index on it, you have to index different fields, etc. But if you just extract the value, for example, HTTP statuses, and you count them, namely, for example, every 10 seconds, and you flush it. So you know that you had 200 codes, etc., etc., for the other example. But what you have to store at this layer is only the timestamp and the metric. So you are sparing a lot of volume, a lot of bandwidth, a lot of things. So it's quite useful. So let's observe and how we did it at OVH. It's important to say that we we did it BPE. It was before Prometheus era. There weren't a Prometheus exporter. And actually, we rewrote one. It's not exactly a Prometheus exporter because it exports a format, a HTTP format that is kind of like Prometheus, but we don't use Prometheus, so it's quite the same. But there was actually an existing HAProxy exporter, but we didn't use it because it was not sustaining our workload. We didn't succeed in collecting metrics quickly enough, so we had to rewrite one with performance in mind. So when you collect the metrics, Willie said in the keynote that there are many, many insightful stats, but you see that there maybe you don't get the sense behind it. So now there is a documentation for each one of those stats. So it's kind of it should be useful. But here with this exporter, you can just choose which one of the metrics you want to get. So you can just select and fine-grain. Once we get those metrics, we export them, but we have a small daemon on each load balancer that is actually collecting metrics and with a DFO strategy. DFO is disk failover. So we flush the metrics on disk, because if we lose the network or the service and we cannot push metrics, we will have them stored, and when the network comes back, we will flush them back. So when we flush it, this component is open source. It's named Beamium, if you want, on the GitHub OVH. We push on a multi-stage time series infrastructure. Why? Because at first, we have a live instance, which is in memory computing. And we use it for fine-grained operations, for example, scaling, monitoring, etc., etc. We use it also for aggregating data, because when you have a lot of data separated in different clusters, you want to aggregate them. And it's why, actually, we have a multi-stage for this. At the first stage, we use a really short retention strategy, but mostly for monitoring purpose. And we first try to aggregate per front-end, back-end, etc. on a customer scope. And then we will push these aggregated metrics on the second stage, which provide a global insight of the platform. But still, at this stage, we don't have a long retention. We have a day's retention, because it's still in memory. But we are global. So we have the total view for customers about how their global load balancing experience is behaving, etc. And then we aggregate per customer with different metrics, and we push them on a cloud infrastructure, when we have years of retention if we want. So we have really these different strategies about time series. And it's quite important because there is a huge reduction factor in terms of unique time series. On the first layer, we have dozens of millions of unique time series. It's not the right version of the slide button. Okay. The first layer is really the fine-grained raw data. So there is millions and millions of time series. Even if it's not an issue to have them on the cloud, because we have multi-hundred millions of time series on the cloud, when you operate, it's better to have a better management of your time series. So from, let's say, 100 million time series, the second stage have only 10 million, and we keep only 100,000 at the end for the customers. So you see that if we had to keep, with a long retention, 100 million time series, the cost wouldn't be the same. So why collecting metrics? Actually, we do a lot of things with metrics. And you can predict the future. Yeah. So how we do it? Here is an example based on memory, but it could be HTTP request, for example. You see there is a trend in the graph, and it's raising, 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 raising. Oh, not good. Because since it's memory, right, there is a limit, a hardware limit. And here we materialized it with the green line, and we are going to hit the wall, actually. So what we can do is that we can extract the trend of the series, and then we can forecast it. And if we forecast, the crossing lines is when we hit the wall. OK? So if we hit the wall, we can anticipate any actions. And we can say, oh, we have to move before the incident. The trend is a way to forecast, but we can have other strategies. For example, we can forecast the global signal, not the trend. And we see that the crossing time is not exactly the same. So given the workload, the use case, the forecasting strategy can be different. What to do now? Well, we can alert, we can annotate in a dashboard, we can auto-scale a service. For example, if it would have been HTTP request, okay, we are going to hit a wall, we need more instances, so we can actually scale the service. This is all achieved in a single request in our time series database. So it's not analysis, it's not big data, it's just one query for a given load balancing experience for a customer that will say, OK, now you need to act. And we could act through the time series database, but we don't do it. Another approach, oh, I'm missing my best slide. Oh, too bad. There is another approach of this. Here, I said that it's a single query inside the time series database, but we also have a different infrastructure for AutoML, auto machine learning, and we train models so that we can go further than this. Because here, this example is really simple. It's globally a trend and a linear regression. You forecast it, OK, job done. But what if you have seasons in your signal? And what if your signal have a week seasonality or monthly seasonality? And if I need to forecast, but I don't have the global picture, my forecast doesn't reflect what will come, actually. This is where a trained model helps us to anticipate. And if you want to try this, it's free. It's a free service of OVH. You can try it on labs.ovh.com. It's called Prescience. And there is a time series forecasting algorithm based on SARIMA. SARIMA is actually a seasonality moving average algorithm. But it's quite interesting in terms of time series forecasting. We can also detect anomalies. With all those algorithms, we also can maybe do ESD score or Z-score test to get actually the deviance. I guess it's deviance in English, yeah, right? Deviation? Deviation? OK, well. So once you have this, you see on this graph that the outliers will be the most uncommon values that you have. So the spikes here, when I annotated it, it represents that I could take actions on this. Or if you see latencies or weird events, you can have it. You get it from your time series. So it's really insightful, and you can do a lot of things with a proper time series database. So all this is pretty classic, right? It's just operating a service, collecting metrics, etc., etc. So now, what is new in terms of era with observability? Well, SPOE, actually. So I was planning to explain what was SPOE, but Pierre did it before, so I will shorten a bit the presentation. But we tend to all speak in terms of HAProxy like a Swiss Army knife, you know. Actually, SPOE is like if we add a bazooka as a tool inside the Swiss Army knife, because this kind of thing make HAProxy like a framework that you can extend, and you can do a lot of things, actually. Here is a simple example. Oh, no, I don't have my tracing. Oh, sorry. So the idea was to explain how we could do open tracing, for example, based on SPOE. What is SPOE? Globally, it's based on the filter engine, and you will trigger some event. For example, a trigger on front-end HTTP request. And when you hit these kind of actions, you can act. And here, I could get the trace ID and span ID from a request. Okay? So, on the response, I can get the same. And if I close the time window between the request and the time, I can flush the span on the tracing framework, so that I get visibility and observability about the full tracing between my clients, load balancer, server, etc. So I've understood that HAProxy is implementing open tracing, right, or something like this. There is something in this way. But you could have your own tracing solution, and maybe the open tracing wouldn't be compatible with your solution. So this makes you able to implement your own strategy about tracing or authentication, as we saw previously. And apparently, the HAProxy team has a message for you, maybe. So. So it was a small quickie about observability. Thank you, and maybe you have a few questions.